which I'm going just to pass through the reading. So the information says to say we have the following info of 0.75 liters per second per 100 meter. The canal info got 36 liters per second, and as well as the required application, which is a 150. The spacing of the fallows, which is 800 millimeters. The field area is 3.8 hectares. And the last bit is the width of the field, that is 120 meters. So we are going to have our calculations here, which will be our solutions. Right? So the first thing that we're going to do is find the what? The time, right? So we're going to say time is equal to what? D times S times what? L. Right? Divide this by what? X cubed. Okay. So we have to know to say, anyway, you know already to say D, the units for D are supposed to be what? In millimeters, right? Then the units for S are supposed to be what? In meters. Then the units for L, which is our length, is supposed to be what? In meters as well. Okay? Then the Q is supposed to be in liters, okay? Liters per second, right? If I'm not mistaken. So that's what we are supposed to have. So now we can take in through our calculations. Remember, this is our Q in this case that we have to calculate at the end of the day. You may not be given, but you have to calculate at the end of the day. So let's get started. Our D in this case is the required what? Application. So this one is our D. So already for our D we have it is what? 150. And we want to say this 150 is already in what? In millimeters. So there's no need of what? Conversion, right? Okay. So let's go to our spacing. The spacing is what? 800 millimeters, right? So we have to take it to what? In meters, okay? Yeah. So we may say 1 meter is equal to 1,000 what? Millimeters, right? Okay. So we are looking for X is equal to 8 what? 800, right? So it would be 1 meter times what? Equal to X times 1,000 millimeter divided by 1,000 millimeter like that. So this will cancel, the millimeter and there, they will cancel, right? So we remain with the meter here. What's this in here? 0.8 is equal to our X. So therefore, our X is equal to 0.8 what? Meters. So this will be what? Our spacing. So this is going to be our spacing. So our spacing here is what? 0.8 times. Now, let's find the length of the field. Now remember, we are not given the length in our calculations. So we have to find the length. But where do we get the length? We are going to get the length from these two values, which is the field area and the width of the what? The field. Okay? This is more like it's like this. We are given the area of the field. We are given the area of the field. I don't know, like something like that. And we are given also the what? The width. Let's get, for instance, we say this from here. It is this, which is a what? 120. And we are given the area to say the area is called what? 3.8 hectares. Let's have something that looks like that. Now, from this information, given the area and the width, we can find our length using the simple formula that we have and that we know. So, it will be area is equal to L times what? B. In this case, our area is how much? 3.8 hectares is equal to L times our width is what? 120. Okay? Of which you see our width. So in this case, this hectare we can take it to area. We all know that the units for area are what? Meter what? Square, right? Or square meter. So we all know to say a 1 hectare is equal to 10 what? 10,000, right? What about 3 what? x. So x is equal to, what is 3.8 times this? 3.8 times 10,000. You get how much? 38,000, right? This is in meter what? Square. So we all want to say it is 38,000 meter square is equal to L times what? 120. Remember this 120 has got a what? A meter there. So we are going to divide this by what? 120 meter divided by 120 meter to remain with what? L. So this cancels. 1m goes. With 1m here goes. We remain with what? 1m, right? So we are going to say our length is equal to, what is 120 into this? 316 point what? 666, like that, right? So we can just round off to 7. So this is what? Our length of the field. So we have found our length. Our length is 316.7 meters, like that. I hope it's clear to everyone how we find the length given the area of the field. Use this formula, just like that. Okay, so our length, which is L in this case, is 316.7. Okay, then we divide it by that figure there. Now let's find our Q. I'm going to get rid of this. So we have to find our Q. So in this case, we all know to say finding our Q is something that is very simple. And it's of everyone's ability. So our Q is equal to this. The follow what? The follow info. So you say our Q is equal to the follow info times the follow length. Follow length. Our follow info is how much? 0.7, right? 5, like that. Okay? Times our length is how much? 316.7, right? Let's find our Q. What is this times this? Just fill out a little bit. Ma? 287.525, like this. Okay, so when we get this number, we all know that we have to divide by what? 100, right? So we divide this by 100. Okay, what number do we get? 2.37525, like this. Okay, so this number, it will be 2.37, let's say 8, right? If we can be precise that way. So this one is our what? Our Q. This one is liter per what? A second. Are we okay? Okay. So that's our Q. So the Q, for you to find the Q, is just you need to find the follow info, which will be given in the question, times the follow length, which you may be given or which may require you to calculate, just like that. So our Q here in this case is 2.38, like that. Though with the issues of rounding off and figures, your values may be a little bit different, but just have it that way to say this is the way it's supposed to be solved. Okay, we continue, right? So our time in this case is equal to, let's do the mathematics here. 150 times 0.8 times 316.7. What is the answer that we get? 3004. Right? It's no point. Okay, we divide this by, what is this times this?
8568. 8568.
8568, right? Now let's do the division here.
4.44.
4.43. 3. Ma?
5.
5, 5.
7, 4, 2, 3.
Yes, sir.
Just like this. So we can round off here, right?
Yeah.
So we can have a 4.44 like this, right? Let's take for instance these are what?
Hours.
Okay, since here we are respecting hours, so let's take for instance these are what? Hours. So this is the time that we are supposed to do what? To calculate just like that. Anywhere you're not clear, so that we explain. Finding the L, you get it from the area, I've shown you. Finding the Q, you multiply the follow info times the follow length, just like that. You okay? Good to go? Okay, so this is our time. We may have to take note of this time because we may have to use it as we go. Our time is got 4.4, right? Like that. We may have to use it as we proceed with our calculations. So, okay, so the next thing we are taught to calculate is what? The number of furrows, right? Yeah. Number of furrows that can be irrigated at once or at a go with that time that is 4.4 hours. So the number, find the number of furrows is very simple. So this is equal to the canal info. You divide this by the follow what? Follow info, right? Follow info. Now remember, this is just whereby if you take things for instance, in reality, this is your, let me say, this is your stream. This is your stream of water going like this. Then you've got furrows like that. Now we are going to look at the issue of water entering the field from those points. These can be called the siphons, right? So to find how many furrows will be irrigated, we are going to divide how much water is going through the stream, and we divide it by how much water is doing what? Going into the what? The furrow. That's why it is canal inflow, this flow, divide by furrow inflow, this flow. Okay? That's why it's coming from. Then this will be having our formula there. What's our canal inflow? Sorry, here. Canal inflow is what? 36 liters per what? Per second. Now remember that when you are calculating for time, when you are calculating for what? For time, right? We said it is D times S times what? L, right? Divide by 3 what? Times Q, right? Yeah. We said the units for Q are what? Meter per watt per second. So you get this value that you got here and put it where? Here. It was how much? What was the value of Q? 2.38, right? Liter per second. Though this value is supposed to be rounded off, as most we have been doing, but in this case, we can't round off this figure is less than what? 5. So we leave it in decimal. Okay? That's why it is just in decimal. Though you may have to think of getting to the bigger whole number, which is 3, but no, just leave it this way. Because you can't round off. Let's do the mathematics there. How many do we get? How many furrows do we get? 15 points. 36. 26. Okay, so this is the number of furrows, but in this case, we can't round off to get a what? A 16, right? So we just end at 15 what? Furrows. So this means to say, at a go, when time is taken to be 4 minutes, if we take time to be 4 hours for 4 minutes, it means 15 furrows will be what?